The Effect of Angle Change on Force by Pavan Kreti, Daniel Cao, and Ivan Rodriguez Oliveros. The big picture, or main idea, of our project revolves around two fundamental concepts: gravitational acceleration and tension. Gravitational acceleration is the acceleration on an object caused by the force of gravitation, and tension may be described as the pulling force transmitted axially by means of string, cable, chain, or similar one-dimensional continuous object, or by each end of a rod, thrust member, or similar three-dimensional object. In our project, we'll be using two fundamental equations, one of which is Newton's law of motion and the second is the sine function. Newton's second law of motion can be described as the relationship between an object's mass and the amount of force needed to accelerate it, and the sine function is the trigonometric function of an angle. Introduction. Our topic is about observing the relation between the angle of the ramp and the amount of force or tension that is increasing. The scientific question being asked is, how does the angle affect the amount of force needed, and how can I calculate gravitational acceleration in this experiment? The required materials include a ramp, string, force sensors, smart car, angle indicator, metal rod, a blocker, metal rod stand, ramp rod connector, computer, Pascal adapter, paper, textbooks, and the ramp stand. To conduct this experiment, we have a procedure of 10 simple steps. Step 1 is to gather all the materials and set up the Pascal capstone to find the force being exerted over time. Step 2 is to attach the angle indicator to the middle of the track. Step 3 is to attach the stands and stabilizers to the base of the side of the track. Step 4 is place the stabilizing base on the table and secure the rod to it. Step 5 is to attach the guard on one end of the track. Step 6 is to attach the force sensor to the other end of the track. Step 7 is to tie the car to the hook of the force sensor. Step 8 is to change the angle of the ramp starting at 5 degrees and increasing all the way in increments of 5 to 70 degrees. The 9th step is to record the force pulling on the car, and the 10th step is to analyze the data. For this lab, standard lab safety is required. This is the picture of our experimental setup at 35 degrees. This is an experimental setup at 60 degrees and 70 degrees. To the left, we have the angle versus force data table, and to the right, we have a graph of these points. As you can see, we've gathered these points through our actual experiment, and in the next slide, we will talk about how to linearize these data points. This is the linearized data points, and as you can see, the trend line perfectly matches the data points. Calculations. One purpose of this experiment was to find gravitational acceleration. We can do this by the following. All we have here is algebraic manipulation of the original equation, which is m times g times sine theta is equal to the tension force. In our experiment, we've calculated that the force of gravity is 9.803 meters per second. This gives us a percent error of 0.0295%, which is fairly accurate. Based on our observations, we can tell that there was a very clear change in angle that had a direct force on the tension of the string. The greater the angle, the greater the effect of gravity had on the car, thus causing the increase in force. Our graphs perfectly reflect this relationship. They show a perfect linear relationship between the increase in angle and the tension force. In the analysis and discussion, we can see that as seen from the graph and data, the force linearly increased. As seen from the data table, the greater the angle would result in greater force. This is because there is a greater angle. There is more vertical gravitational force on the system and less normal force to counter it. Real-life connection and further applications. In the real world, this concept is important because it applies to many mechanics. For example, during construction, heavy loads of material are manually carried up either by people or by cranes. With the knowledge gained from this project, one can choose the optimum angle to lift items up. As part of our experiment, we created a set of investigative questions that would better help us understand the project. Some of this include what is the relationship between the mass of the car and the tension of the string, and others include what is the relationship between angle and force. connections. The force versus angle concept has been thought about throughout history, most commonly seen in how an inclined plane is used to reduce the amount of force required to move an object and keep the object moving using the same amount of work done. This is due to the fact that distance will increase when force decreases, keeping the amount of work the same. For our ELA connection, we did a personal narrative, which can be seen here. Thank you for watching Harmony Public Schools.